In this video, we're looking at a cart that's being accelerated by a fan from rest. And what we know in this problem is the total time for the acceleration process and the final speed. And we're going to answer a variety of questions about work and energy and momentum. So the first part is to compute the total work done by the fan on the cart. So all we have to do here is observe the final kinetic energy of the cart. That energy was input into the cart by the fan, and so the total work done by the fan is equal to that final kinetic energy. That final kinetic energy is given by 1/2 mv squared, and we plug the numbers in, and when we run the numbers, we get 3.125 joules of work. In part B, we're asked for the average power output of the fan, and that's just the rate of the energy transfer, or the rate at which work was done. And we plug the numbers in. The total work done was 3.125 joules. The time it took was 5.7 seconds. And to 3 sig figs, we get 0.548 watts. In part C, we're asked for the total impulse delivered to the cart. An impulse is just the change in momentum. So that's the final momentum minus the initial momentum, but of course the initial momentum was 0 because we started from rest. So the total impulse is just equal to the final momentum, which is the mass times the final velocity. And we plug the numbers in, we have 1.0 kilograms and a final velocity of 2.5 meters per second. So our impulse is 2.5 kilogram meters per second. Finally, in part D, we're asked to compute the average force exerted on the cart by the fan. Well, the average force is just the rate of change in momentum. So it's our change in momentum, delta P, divided by delta T. So we take our answer from part C, 2.5 kilogram meters per second, and we divide by how long it took, delta T, that was 5.7 seconds. Into 3 significant digits, this gives us 0.439 newtons. Just as an added bonus here, let's look at the units in that last calculation. The numerator was momentum, and that's kilogram meters per second. The units in the denominator were seconds. So this gives me units of kilogram meters per second squared. But we know from Newton's second law, F equals ma, that a newton, that's on the left-hand side, is equal to a kilogram, that's the units of mass, times units of acceleration, which are meters per second squared. And so that kilogram meter per second squared is a newton. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.